Okay, so we're talking about tests about the population proportion. Okay, so let's do a little bit of review. 9.1, we talked about significance testing, right? We talked about significance testing, and we said that we had a ho and we had a ha. And the ho, we said we were going to write down the thing that we were trying to disprove, right? And the ha, we were going to write down the thing that we think is true, right? What we think is true. Okay, we're going to write that as the ha. And then we're going to write the ho as the thing that we're trying to disprove. Okay, and in the end, we were going to find what is called the p-value. And we're going to compare that to the alpha, the significance level, right? And if p-value was greater than alpha, we would fail to reject the ho. We do not have convincing evidence for the ha. Okay, that's if the p-value is greater than alpha. If the p-value is less than alpha, okay, we would reject the ho, which means that we're going to disprove or say that the ho is not correct, and what we thought was true is true all along. And we are going to have convincing evidence for the ha. Okay, all right. So we really want to see it happen. We want the p-value to be small, right? We want the p-value to be small, right? Okay, because that kind of sets us up for everything. If the p-value is smaller than alpha, then I can go ahead and reject the ho, and I can say that yes, I have convincing evidence that what we thought was true all along. Okay, all right. So that's where we're at. So this is what we're trying to do, and obviously there are two different things, right? We can do the population proportion, we can do the population mean. So 9.2 is going to be about the proportion, 9.3 is going to be about the mean, which makes sense. Okay, all right. So let's go to page, where are we at? We are on page 568, tests about a population proportion. Okay, so we're now, if you go to top of page 569, we have the conditions that we need to be met in order to do the significance testing. And if you read those are our nice friends, trusted and true, random sample, right? The n cannot be greater than 10%. You cannot oversample. And last but not least, the large counts, right? NP, N1 minus P. Okay, so you've seen all these, you know these, right? These are the same three conditions that you had to check for confidence intervals, right? Okay, so instead of a confidence intervals, now we're talking about significance testing, okay? All right, so let's go ahead and look at the example there, get a job. According to the US Census Bureau, the proportion of students in high school who have a part-time job is 0.25. An administrator at a local high school suspects that the proportion of students at her school who have a part-time job is less than the national figure. She would like to carry out the test using a 5% alpha level. So again, since we are trying to disprove that the proportion is equal to 0.25, this would be the whole. What we think is true is this. Okay, the whole, the ha is like that. And we have alpha is equal to 0.05. Okay, so what are we trying to do here? Where P is the true proportion of all students at the school have a part-time job. The administrator selects a random sample of 200 students from the school and finds that 39 of them have a part-time job. Check the conditions for performing a significance test are met. Okay, so number one is a random sample. So it was correct, we're good, it's a random sample. Number two, we are 200 people is the small n, so that's the small n. And we're gonna assume that the larger n is greater than 2,000 because it was a large high school, correct? So it was a large high school. So we're gonna assume that's correct. And then we have 200, so NP. For the large counts, we have 200 times 0.25. And for N1 minus P, we're gonna have 200, 1 minus 0.25. So this is gonna be what? This is gonna be 50, this is gonna be 150. So yes, both of them are larger than 10. So the large counts also are good, right? So it does check all the boxes there, right? Okay, so let's go ahead and actually calculate, see how we actually calculate the p-value, okay? So let's go to, in the book, they were using the basketball one, and the basketball one is where the guy said he was an 80% free throw shooter and we gave him the ball. He made 32 out of 50 for a grand total of 0.64. So on this one, the whole was, I'm an 80% free throw shooter. What we are suspecting is that no, you are less than an 80% free throw shooter. Okay, and we're going to use an alpha of 0.05, I believe, is it? Doesn't say, so if it doesn't say, that means that it is 0.05. Okay, so that's another thing that we do need to kind of let you guys know. If there is no significance level, if the significance level is not given to you, we are going to assume the alpha to be 0.05 because we had agreed that statistically significant was 5%, right? So that's where the alpha comes from there, okay? All right, so let's go and see what we have here. So this is where we are at. So let's check the conditions. So actually we'll do the state. We are gonna do a significance testing for this guy here, whole of this and half of that using a significance level of 0.05. That's what I state. Next thing to do is then we plan. In plan, we're going to check the conditions, okay? Not like you guys did not check them during the test, okay? You have to check these conditions. So number one, it is a random sample because you're just shooting free throws, right? It's a random sample, okay? Number two, and yeah, because the guy has many free throws, right? So 50 of them is less than that. 3, N was 50, P is 0.8, 50 times 1 minus 0.8. So this is gonna be 40, this is gonna be 10. Both of them are greater than or equal to 10. So the large currents is satisfied, we're good. So now we're going to do, okay? So the do part is gonna be, how do I do this? So we're gonna check, we're gonna say that the sampling distribution is normal, okay? Sampling distribution is normal. So I'm just gonna do a standardized normal test and see where we're at. So if I do a standard, if I standardize it, okay, so I really don't have to, I can do it either way, right? 0.8 over here is 0.64, right? So I need to find out how many sigmas this is away, right? because this is what we're looking at. We were trying to find this guy here, right? Okay, this is our p-value right here. Right here, this is our p-value. Okay, because this is what he shot, 0.04, 0.64, right? So the sigma here was what? The sigma, remember, if you go back, was P1 minus P over N, right? So that was our P. And if you do that, I'm going to get 0.8 times 0.2 divided by 50, right? If I do this, I get, what do I get? I get 0.0566, 0.0566. So that's my sigma. Okay, so how many sigmas is this away? Nothing more than, it's a z-score, right? Divided by 0.0566. And if I do that, I am going to get negative 2.83, negative 2.83. So to find this guy here, what am I going to do? 0.0283, so I can look it up in the back of the tables, or I can do norm CDF, and it's a standardized now, right? I standardized it because I subtracted all this stuff out, right? So I can do it either way. I can do it just norm CDF of what? I can do a norm CDF of 0 to 0.64, 0.8 at 0.0566. Or if I do the standardized one, I can do norm CDF. Since I already went to the trouble of finding this out, I could go 0, well not 0, but negative 100 to negative 2.83, negative 100 to negative 2.83, right? 0 and 1. Right, I can do that. Either one of those, I should get the same result. If I do that, the norm CDF, and I do that, what do I get? I get 0.0023. 0.0023, so I'm going to get 0.23%. Okay, so now let's conclude. I conclude that my p-value is less than the 5%. P-value is less than the 5%. So p is less than alpha. Therefore, I reject the whole. And I conclude that I have convincing evidence that the true proportion is less than 0.8. Okay, all right, so that's how that goes. Go in the middle of page 570, there's a green box, which kind of goes over how you find the standardized test statistics. And that is this guy right here. Okay, that's the standardized test statistic. Okay, and that allows you to use that. Okay, all right. So let's go back and do the same thing for our example that we did on the part-time jobs, right? On the part-time jobs one, the national statistic was that P is equal to 0.25. We think that the P was that. This is the ho, this is the ha. Alpha of 0.05. N was equal to 200. And how many? There were 39, right? There were 39. Okay, there were 39. Okay, so state. We're going to do a significance testing of the ho being that, the ha being that, with an alpha level of this. Plan check the boxes. We already checked the boxes on the previous one. It was a random sample and the n was less than 0.1 n and the large counts were good for us. Okay, so let's go ahead and do. We're gonna do, let's find the standardized test statistics. So we did 30, we found 39 out of 200. That's what we found. Okay, we're gonna subtract this from 0.25 because that's what we think it is, or what they thought, what we told us it's supposed to be. And then we're gonna go P is 0.25 times 1 minus P over 200. Okay, if we do that, where are we? If we do that, we get negative 1.8. Negative 1.8. So again, we're going to do the norm CDF, negative 100 to negative 1.801. And if I do that, what am I going to get? I am going to get 0.0359. 0.0359. So my p-value is 3.59. My p-value is 3.59, less than the alpha. P is less than the alpha. So to conclude, we say that the p-value for 3.59 is less than the alpha, which means that we reject the whole. We have convincing evidence that the true p is less than 0.25. And that's it. Anything else that we asked for? A, explain why the sample result gives some evidence. Well, the some evidence is this guy right here, right? This is the some evidence because we actually did one and we found that that was 0.195, I believe, right? 0.195. So yes, we have some evidence because this was less than 0.25, right? Okay. And then B, calculate standardized, we did that, and what conclusions to make, and we're over with that. Okay, so let's go ahead and flip it over. And, oh, so we're good. We're good. We are done with the first part.